So here's the idea. Here you have your powers chart, and we are going to be solving exponential equations. Exponential equations are equations where the variable is in an exponent. So if you had something relatively easy, I'm pretty sure I could give this question to you in grade 9 or 10 and you would get it right. 4 to what power is 16? What's x? 4 to x is equal to 2. But what we're going to do to figure this out is we're going to add a step by saying, in my powers chart, I notice that 4 and 16 are in the same column, right? So that means that I could take 16 and write it as a base of 4 and take that extra step. And if we can write both sides with the same base, does it make sense that if those bases are the same and the equation is the same, then the exponents would have to be the same as well? So for my purple circles, it's obvious that x has to equal 2. But I could give you a less obvious question, like this. 8 to what power is 4? And now we're in trouble. You know that 8 to the 0 is 1, and 8 to the 1 is 8. So it's got to be something between 0 and 1, but the mental math here isn't quite as easy. But on my powers chart, do you see that both 8 and 4 are in the same column as the 2? So I could rewrite 8 as 2 cubed, put it in brackets, still have an x and exponent, and I could rewrite 4 as 2 squared. And our exponent rules from grade 9 are going to come back a lot. What do you do when you have a power to a power? You multiply. So this side will be 2 to the 3x, and this side is 2 squared. And my bases are the same. So what's in the purple, and I'm going to actually write so, because it's just by observation, does it make sense that 3x has to equal 2? And solving for x would have to equal 2/3. And you can try it on your calculator, just to double check it. 8 to the 2/3, it's 4. Perfect. So we're going to get to example 1 here. And that's our goal, to get both sides with the same base, because then we can say the exponents have to be the same. So to start off with, I see 4 and 256. If I go to my powers chart, are 4 and 256 in the same column? Yes, it happens twice. You see they're in the 2's column and also in the 4 column. So you could decide to change 4 to 2 squared, or you could keep 4 and change 256 to 4 to the 4th. Not yet. It will be. You're right. So in order to have this base is on the bottom in the denominator, in order to move it to the top, we'll have to use our negative exponent rule. And now I can do this next step. I can say, so x has to equal minus 4. Because if those two things are equal, the bases are the same, the exponents would have to be the same as well.
You don't have to write that so and then circle the x's, right?
No, you can, if you just write x equals negative 4. But mathematically, there is a mathematical thing you should do to both sides to get rid of the 4's. But we don't know what that is yet. And it's not dividing by 4, because how do you undo a base? You use logs, but we're not there yet. So we'll just do the so part. And just sort of like, how about 27 and 9? Are they in the same column on your powers chart?
Yeah, you can turn 27 into 9 squared.
No. You can change 27 into 3 cubed.
Yeah.
to the x, and this side we change our 9 to 3 squared. And now we have to do our exponent laws. Here we would multiply and get 3x. Here we would multiply and you'd have to distribute, right? You'd get 4x minus 2. And now that your bases are the same, so the 3x has to equal 4x minus 2. If I move the 2 to this side and the 3x to this side, I get that x has to equal 2. Questions for practice on this one are 3, 4,